Similar to last chapter, we're going to predict whether or not there's ionic, covalent, or both present in these compounds. So to start with, we're going to look at these two. So iron nitrate. In this case, the iron and the nitrate, these are a metal and a polyatomic. So this is going to be held together by an ionic bond. However, the NO3 group is made up of nonmetals only, and so these are going to be held together by covalent bonds. So in this case, both are present. And that's going to be true about all of our polyatomics. In the next question, it's NH2, 2CO. So this is going to be nitrogen, hydrogen, carbon, and oxygen, which are all nonmetals. So this is going to be made up of covalent bonds. The next question says to write the name for each covalent compound. So we need to follow the rules that are provided in the reading. And in this case, we're always going to name the first element, which is carbon. And then when appropriate, we're going to use a prefix that matches the number of the suffix. In this case, there's one oxygen, so this is going to be carbon monoxide. Now, there is an important rule here because the prefix for one is actually mono, but we're not going to put two O's next to each other. So it's not monooxide, it's going to be monoxide. The other one is A and O. We're not going to put those next to each other. We're going to drop the A, and it's only going to be a single O. But we can put I and O next to each other, so you could have trioxide. The next one is S2O3. So in this case, we do need to use a prefix in front of the sulfur to let us know that there are two. So it's going to be disulfur, and there are three oxygens, so it's going to be trioxide. So remember, we need to change the ending. This is oxygen, but we're going to change the ending to IDE. And you have two more to practice with. The next one says to take the name, and we're going to write the covalent compound formula. So I have boron, trichloride, which tells me that I have 3 chlorines. The next one is carbon dioxide, CO2. Some people find that it's much easier to take the formula, to take the name and write the formula rather than to generate the name from the formula. And that's okay if you feel that way. The next question says to use the figure 4.4 to determine which atom in each pair has the lower electronegativity. So just a gentle reminder that fluorine is the most electronegative element and cesium is the lowest. So it's going to increase as we go up the column and as we go over from left to right. So in the first pair, I have magnesium and oxygen. Magnesium is over here, not right in highlighter. Magnesium is over here with cesium. Oxygen is closer to fluorine. So in this case, I'm going to predict that magnesium is going to have the smaller electronegativity. If I do the same thing with sulfur and oxygen, the thing to always remember is fluorine has the highest number always, so that means that sulfur must have the lower number by default. When we see the next question, it's calculating molecular mass. We've already done a problem very similar to this in the last chapter, and so you should already feel comfortable doing this type of problem. The next question is about drawing Lewis structures. In this case, we're only going to draw really basic Lewis structures. We're not going to draw very complicated ones. And so what you need to do is always remember that the first element is usually the central element. And we're going to draw its Lewis dot symbol. And remember that the Lewis dot symbol represents the number of valence electrons. And the number of valence electrons are going to be what participates in bonding. Now, I have 3 bromines. Each bromine has a lone electron. Made that too far away. that's available for bonding. So if I remember, bromine has 7 valence electrons because it's in group 7A. When we have electrons paired together like this, these are not going to want to form bonds. Only the ones that are what we call unpaired or lone, N-O-N-E, electrons are going to form bonds. So in this case, what I'm going to do is I'm going to connect the lone electrons between each element to connect them with covalent bonds. So I've done that with purple lines, and this is the Lewis structure. Now it tells you to predict the shape, but we're not going to worry about the shape. We are going to simply practice drawing the structures by connecting the dots. The next one is SF2. So sulfur has 6 valence electrons, 2 which are paired, or 4 which are paired. So 2 pairs and then 2 lone electrons. And fluorine is very similar to bromine in that it has 3 pairs of electrons and 1 lone electron. So I'm going to orientate the lone electrons pointing towards each other and then connect the dots to represent them being connected with covalent bonds. The last one is silicon with hydrogen. So in this case, silicon is in group 4A. It has 4 valence electrons. Hydrogen is group 1A. It has 1 valence electron. So that means that each of the lone electrons on silicon is going to connect to the lone electron on the hydrogen. And we are not going to worry about talking about hydrocarbons at this point because we will revisit them in a later chapter, and so we're not going to cover 4.6 right now.